So let's start on section 1.3 of trigonometry. This will be the first introduction to the 6 trig functions, the 6 trigonometric functions. In order to facilitate this, we need to remember Pythagorean theorem and distance between 2 points. So for Pythagorean theorem, which again is a geometry construct, you have a right triangle. And for the first part here in trigonometry, we're always going to be dealing with right triangles. In a right triangle, the side opposite the right angle is called the hypotenuse. We normally label with a C. And the two sides that make up the right angle, these are called legs. So it has 2 legs and a hypotenuse. We call one side A and one side B. The Pythagorean theorem says that the length of the hypotenuse squared is equal to the length of the first side leg squared plus the length of the second leg squared. It also says the distance between 2 points. Let's say we wanted the distance from this point to this point. Actually, the distance between any 2 points is something, so let's say the distance between these 2 points is length C. C is going to be the square root, and you're only going to have a positive value because distance can only be positive. C is going to be the square root. So if we take the square root of both sides. Now, if we were given 2 points, 2 xy values, the distance between the 2 points is the x of the first value minus the x of the second value squared plus the y of the first value minus the y of the second value squared. We will be using this all the time. So that's a reminder of Pythagorean theorem and the distance formula that we're going to be using. So there are 6 trig formulas, and when you write them, I want you to get used to writing them this way. The 6 trig functions are always functions of angle. So sine of theta, cosine theta, and theta, cotangent theta, secant of theta, and cosecant of theta. I always want you to write this in this view. Sine, cosine, tan, cotan, secant, cosecant. Sine, cosine, tan, cotan, secant, cosecant. I want you to do that because these 2 trig functions are reciprocals of each other. These 2 are reciprocals of each other. These 2 are reciprocals of each other. So really, you only need these 3, and you automatically get the other. Or you need the 3. These 3 will all automatically those by using the reciprocal, swapping the numerator and the denominator. Whenever you have a trig function, the trig function will equal value. You always have to find with the angle. You'll find the sine of theta, the sine of x. X is the sine of A. If A is your angle. So I never want to see a trig function without being followed by an angle notation. So we've got sine, cosine, tan, cotan, secant, cosecant. Let me go ahead and write it again. You're going to write it hundreds of times in this course. Sine, cosine, tan, cotan, secant, cosecant. CSC is cosecant. Now, when we have a representation in a right triangle, some of you might have learned Sakatoa, or someone takes a hold of Harvey or something. I learned old houses are houses of angels. Old houses are houses of angels. Or Sakatoa. These are talking about the sides of the triangle, the right triangle. So let's look at example 1. Example 1 is this triangle. The x is of length 8. The height is of length 15. And there's my angle theta. We're always going to be using theta with respect to the x-axis. Okay, theta is always going to be, so this is not theta up here. Theta is with respect to the x-axis. How did I get this? The problem said to find the 6 trig functions that go through the point 8, 15. So here's my point, 8, 15. That's over x, 8, and up 15. 1, 8, 15. All right, so the first thing I need to do is find the length of the hypotenuse. So my hypotenuse is going to equal square root of, I have a length here, 8 squared plus 15 squared. My hypotenuse is always going to be a positive value, the square root of 64 plus 15 squared is 280. Square root of that, 17. So the length of the hypotenuse for this one triangle is 17. So I want the sine of theta, cosine of theta, tan of theta, cotan of theta, secant of theta, and the cosecant of theta. Myself which sides the triangle is used for each of these trig functions. Is houses are houses angels. O stands for opposite side, H stands for hypotenuse, A stands for adjacent side. An opposite side is not touching the angle. The hypotenuse, of course, is the longest side of the triangle. And the adjacent side is touching the triangle. So if this is my theta, and this is my triangle, the sine of theta is the opposite. This side is not touching theta. Opposite over my hypotenuse. My sine is 15 over 7, which means my cosecant is 17 over 15, because these are always reciprocals. The cosine of theta is the adjacent side. That's the side that's touching the angle or being used to create the angle. So that's going to be 8 adjacent over hypotenuse over 17, which means secant is 17. And the tangent of theta is the opposite side over the adjacent side. Opposite side over the adjacent side. So if my tan is 15 over 8, that means my cotan is 8 over 15. And I will put a box around this. This is my answer. These are the 6 trig functions for the point, I'm sorry, for the angle that goes through the point, 815. Okay, let's try it again. Let's look at example 2. Example 2 on page 142. Side of angle theta in standard position passes through the point -3, -4. -4. So although this is this angle, that's the angle that whose terminal side passes through the point -3, -4. So far we've only seen positive trig functions. The value of trig functions can also be negative. So let's remember this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We're going to remember the acronym all students take calculus. All students take calculus. Go around counterclockwise. This says in the first quadrant, all trig functions are positive. Second quadrant, just sign is positive, which means also cosecant will be positive, but the other two trig functions are negative. In the third quadrant, tan is positive. S stands for sine, C stands for cosine, and T stands for tan. So in the third quadrant, tan is positive. The others are negative. And in the fourth quadrant, cosine is positive. So from this diagram, we're going to create this triangle. From origin. From origin down to the point -3, -4. So what is the length of x? It's 3. I know it's in the negative direction, but that length is over 3. And what's this dimension or length 4? I know it's down 4, but it's of length 4. We're going to rely on our all students take calculus to give us the SIGN side, positive or negative. All right, so let's find the hypotenuse. Hypotenuse is the square root of 3 squared plus 4 squared. So the hypotenuse is going to be the square root of 9 plus 16. So the hypotenuse is going to be 5. So although my original angle for theta is, excuse me, my original angle for theta is an obtuse, actually, it's greater than 180 degrees because it falls in the third quadrant. I can use this triangle to solve for sine of theta, cosine of theta, and tan of theta, and the cosecant of theta. And let's remember, this is both hazard, so the first thing I'm going to do is put in whether they're trig functions. positive or negative. And I know that just by the quadrant. This is in the third quadrant. All students take it. Tan and cotan are going to be positive. I automatically know my cosine and my secant are negative. I automatically know my sine and my cosine are negative. Here's my third. Opposite over hypotenuse is 4/5, which means this is negative 5/5. It's not theta. Adjacent over hypotenuse is 3/5, negative because of the quadrant, which is going to make this negative 5/3. Now, for theta, opposite over adjacent. Well, opposite side is 4, adjacent side is 3. Positive 4/3, which means my cotan positive third or 3/4. And that is my answer for example 2. Okay, let's go on to example 3 on page 143. Here they want us to find the 6 trig functions for the value for angle theta in standard position if the terminal side theta is defined by x plus 2y equals 0. And in the problem, they say that x is greater than or equal to 0. So x is always on, x is always positive. So we'll pick a value for x and find a y. We have to find the point. The difference between this problem and this problem is we were first given a point. Here we're not being given a point, but we can actually find a point. Let's pick a value for x. Let's pick something bigger than 0, an easy value to use. So let's pick x is 2. 2 plus 2y equals 0. Subtract 2 from both sides. 2y equals negative 2. Divide both sides by 2. Y equals negative 1. So even though they started us with an equation of a line, we now have a point. So let's go ahead and draw it. Starting at origin and going through the point to negative 1. To negative 1. Now I know theta goes all the way around here, but we're going to use this as theta. It's called the reference angle. This is enough of a triangle to solve. X is 2, y is 1, means my hypotenuse. All students take calculus. So if I want the sine of theta, cosine of theta, tan of theta, cotan of theta, secant of theta, and cosecant of theta. All students take calculus. Cosine and secant are positive. You know sine is negative, cosecant is negative, tan is negative, cotan is negative. Because of the quadrant, that terminal side falls in. All right, so let's find the hypotenuse. Hypotenuse is going to be 2 squared plus 1 squared. Hypotenuse is going to be the square root of 5. And we're just going to leave it as the square root of 5. Exact value square root of 5. So we have O, houses, R, houses, angels. And here is my theta from origin to the old houses. That's going to be 1 over the square root of 5. Now, math people do not like radicals, square roots in the denominator. So I'm going to multiply that by 1, but a certain way of writing 1. And here it is, because I get the square root of 5. The square root of 5 times the square root of 5 is just 5. So my sine of theta is going to be square root of 5 over 5. And the reciprocal of that is just square root of 5. The reciprocal of 1 over the square root of 5 is just square root of 5 over 1. Now I already have my negative signs in. Cosine, adjacent over hypotenuse. 2 over the square root of 5. Well, again, we want to what's called rationalize the denominator. 2 square root of 5 over 5 multiplying by square root of 5. So that's going to be 2 square root of 5 over 5. And the reciprocal is going to be the square root of 5 over 2. And is opposite over adjacent. Opposite side is 1, and the adjacent side is 2. So that's going to be negative a half, and the cotan is going to be negative 2. That's the answer to my example 3. So we will be making right triangles out of the terminal side of the angle, finding what quadrant the terminal side falls in. Outside, drawing a right triangle, figuring out the length of all sides, adjacent, opposite, and hypotenuse, and then using the SIGN sign, all students take calculus to find what our trig function values will be. But now, there are some angles that it's not going to be possible to draw a right triangle, and those would be angles whose terminal side is actually on an axis. Those are called quadrantal angles. Quadrantal angles. Those are angles whose terminal side is actually on an axis. Like 90 degrees. Or like 180 degrees. The terminal side is on either the x-axis or the y-axis. You're not going to be able to always draw a box. So let's remember. If you look on page 144, if the terminal side of the quadrantal angle lies along the y-axis, the terminal side, if it lies along the y-axis, then tangent and secant are undefined. U and D, put U and D undefined. If the terminal side is along the x-axis, then you're going to find that the cotan and cosecant are undefined. Why is that? That's because your length, your distance is going to be 0, and you can never divide by 0. So when you start taking reciprocals, let's say this point was 0, 3. So if I had 3 over 0, that would not be defined. So for your quadrantal angles, there are going to be some trig functions that are not defined. And so this is getting you ready for the next thing that we'll learn, In this section, they just say, know that they're undefined. But this is the point, x is 1, y is 0. This is the point, x is 0, y is 1. This is the point, x is negative 1, y is 0. And this is the point, x is 0, y is negative 1. If your terminal side falls on one of these points, the x value is the cosine of the angle. The y value is the sine. This would be the point 0, 1. A 90-degree angle would have a cosine of 0 and a sine of 1. And what's the identity is that the tan of an angle is equal to the sine of the angle over the cosine of the angle. So that's as far as I want to get now. Just realize that for your right angles or your straight angles, some of your trig functions will be undefined because you can never divide by 0.